Hi guys, how are you? Hope you're doing great. Today we're going to start our new module, which is 19, lesson 19.1, central angles and inscribed angles, prepared by me, Ms. Salma Ahmed. Let's see the contents that we are going to talk about. Number 1, investigating central angles and inscribed angles. Number 2, understanding arcs and arc measures. Number 3, investigating the inscribed angle theorem. Let's start investigating central angles and inscribed angles. What is a chord? Is a segment whose endpoints lie on a circle. So if I have these two different circles, so if I have 2 points, which is B and A, and I join them, this is called a chord. So the chord is a line segment between 2 endpoints lying on the circle. Another one, if I join B and D, this is called another chord. Yes. Move to the other circle, the same idea. If I have 2 points on the circle, I join them, it's called a chord. And another one, which is a chord. So here the chords are AB line segment and BD line segment. Let's remember and take a note that the diameter is a special chord that passes through the center. So here we have a point on the circle. If I joined it to the center of the circle, so it's called radius. If I complete the line to the other side of the circle, it's called a diameter. So here we have the diameter here is called a chord because it's a special case from the chord. So it has 2 endpoints on the circle, but it's passing through the center of the circle. What is a central angle? Is an angle with measure less than or equals to 180, whose vertex lies at the center of the circle. So here we have the 2 circles. So I'm talking about the vertex which is in the middle of the circle, which is at the center. If I join C by the point on the circle, this is called a radius. So here I have 1 radius, or I'm going to connect C by D, and we have another radius. So these 2 radii, between them or the included angle is called a central angle. So here we have the central angle and it's called ACD, or we can call it DCA. Another one on the other side, I have 2 radius and the included angle between them, it is called a central angle. So here we have another central angle, the angle less than or equals 180. So here we have the central angle is called ACD or DCA. What is an inscribed angle? Is an angle whose vertex lies on a circle and whose sides contain chords of the circle. Here we have the same circles. So he's talking about the vertex lie on the circle. So here we have this point, chord and chord, the included angle here, and the vertex is on the circle. The included angle is called inscribed angle. So here we have angle ABD, or we can call it DBA. Here I have the same idea. I have 2 chords. So it is formed from 2 chords, and the angle between them, or the included angle, is called inscribed angle. So here we have ABD or BDA is an inscribed angle. Examples. Identify the chords, inscribed angles, and central angles in the figure. The center of the circles in example from 1 to 4 is C. Here we have this circle and the center is C. We need to find the chord. So let's recall the definition that we took. We have 2 endpoints on the circle, so it's a line segment and join 2 endpoints on the circle. So this is called DE, which is a chord. And we have another one, which is EF, 2 endpoints. So this is a line segment with 2 endpoints lie on a circle. So this is called a chord. What is inscribed angle? We took before that inscribed angle that have the vertex on the circle, and it is formed from two chords. So here we have chord DE and chord DF. So the included angle is called an inscribed angle. We can call it DEF. Okay, what is a central angle? From its name, central angle, so we are going to search at the center, that the vertex is at the center. So I joined D by C, it's a radius, and C by F, it's a radius. If I call it, it's called DCF, which is the included angle between the two radii. It's called a central angle. Let's have another example. Here I have a different one. I need to find the chords. So the chords are two endpoints on the circle, between them a line segment. So I have SR and I have ST also. I have SCU as if it is a diameter and we call it chord. So I have SU. I have ST as we said before, and I have RT, which is another diameter of a circle, and it's called a chord. What is an inscribed angle? Inscribed angle that the vertex is on the circle or lies on the circle. So I can mention SRT, I can mention RSU, I can mention UST. Let's see the answers. We have RST, RST. So this angle, angle S, and we have RSU. So we have this small one. We have UST, which is the other one. We have STR, which is inscribed angle here, because the vertex on the circle. Okay, let's see the last one, which is RTS. Okay, let's move to the central angle. The central angle, so we are talking about the center, which is the vertex of the angle. So here I have many. I have TCU, because I'm talking about two radii, and the included angle is a central angle. We have many. Let's start RCS, RCS. And I have another one, SCT. We have the other one here. We have RCT, RCT. Why it's RCT? Because it's a straight angle which is 180. We can call it a central angle. Also SCU, also the same definition, that we have a straight angle with measure 180, so we can call it a central angle. We have RCU, RCU, this one, this part, and final one we have UCT, UCT, the obtuse angle here. So all of them are central angles. More examples. If I have the same example, I need to get the chord, the inscribed angle, and the central angle. So what about the chords? The chords are line segment joined two endpoints on the circle. So this is called a chord, DG, and we have another one, DF. We have another EG, and we have EF. So let's see the answers. DF, DG, so DF and DG. We have EF, and we have EG. What is the inscribed angles? The inscribed angles that the center, sorry, the vertex on the circle. So here I have an inscribed angle, which is GDF, and I have another one here down, which is angle angle G, DGE. We have another one here, which is GEF, and the one down at the F, which is EFD. Let's see the answers. DGE, DGE, which is the small one here. DFE, so I have the other one down. Now I have FDG, which is this one on the left, and I have the final one, FEG, which is on the right up. What about the central angles? Here I don't have any central angles because the center doesn't have any two radii to form the central angle. So here we have none. Another example, I need to find the chord, the inscribed angle, and the central angle. So the chord, only the one that I have is AE, which is the diameter. So here the chord is only AE, line segment. What is the inscribed angle? Inscribed angle, that I have two chords that form an angle. So here I don't have two chords to form an angle, so I don't have any inscribed angles. The central angle, we have many. We have ACB, this obtuse one. We have another one down obtuse, ACD. We have ACE, which is the diameter. It's a straight angle, 180, and it's called a central angle. We have angle BCE and angle DCD, ECD. Let's see the answers. ACB, as we said, which is the obtuse one. ACE, ACE, which is the straight angle. ACD, ACD, which is the obtuse one. And we have BCE, sorry, which is this one. And we have DCE, the other small one here. The final one is BCD, which is all of this, the central angle between this radius and that one. So it's called BCD. Understanding arcs and arc measures. What is an arc? Is a continuous portion of a circle consisting of 2 points called the endpoints of the arc and all the points on the circle between them. So here we have different types of arcs. So the arc, the first one is minor arc. So what is a minor arc? From its name, it's a smaller one. So the arc is the portion of points between these two endpoints on the circle. So this arc between A and B, it's called arc AB, and this is called minor. So this arc is between this radius and this and that radius, or this straight line and that straight line, these two endpoints, and the one between them is called a minor arc. Is an arc whose points are on or in the internal or the internal of a corresponding central angle. So if I have this central angle, which is ACB, the arc in front of it is called arc minor arc AB. So the measure, or the measure of arc AB is the same measure of the angle or the central angle. So the central angle is equal. If it is equal 40, so that arc is equals 40. If it is 90, the arc is equals 90. So measure of arc AB is equal measure of angle ACB. Another type of arcs, major arc. So from its name, the major, which is the bigger. So here we have is an arc whose points are on or in the external or the exterior of the corresponding central angle. So I'm talking about the central angle, and I'm talking about all of this arc outside of the central angle. So we have to we have to call it by three letters, A, D, B. So this big arc is called by three capital letters, A, D, B. So how can we get the measure? If I have this central angle, I can get the measure of the major one, which is 360 minus angle ACB, which is the central angle. Another one, semicircle. What is a semicircle? Semicircle, it's about, or from its name, we can conclude that it's half of the circle. So if I'm talking about ADB, and AB is a diameter passing through the center. So the arc here is called ADB, and it's called a semicircle. Is an arc whose endpoints are the points of a diameter. So the arc here is the endpoints of the diameter of the circle. The measure of it is 180, of course. It's a straight angle here. Adjacent arcs. What is adjacent arcs? Are arcs of the same circle that intersect in exactly one point. So if I have arc DE and I have another arc which is EF, so they are intersecting at E. So here we can conclude that arc addition postulate the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So here I have, if I need to find the angle, the arc, the measure of arc ADB. So I can get arc AD plus arc BD. Okay, so these two arcs, I can add them to get all of that arc. Example. If measure angle BCD, BCD, which is this small angle, it is 18 degrees, and measure of arc EF, it is 33. Determine measure of arc ABD. So we need to find all of this arc, ABD, using the theorem and the postulates, and given that an AF and BE intersects at point C. Okay, if the arc EF is 33, so the measure of angle ECF is equal 33. So the arc is equal to the central angle, as we mentioned before. So measure of angle ECF is the same measure of angle ACB because they are vertical angles. So it's a relation vertical angle theorem. Here I have measure of angle ACB is 33, and I know measure of angle BCD, which is 18. So if I add them by using addition postulates, we can find, if I add this arc, or I add this angle and that angle, the angles are equal, which are central angles, are equal to the arcs outside. So if I add the angle ACB and angle BCD by using arc addition postulates, I can find the answer. So this is called 33 and 18. So the answer, it gives me 51. So this is the measure of arc ABD. Another example. If measure of arc JK is 27 degrees, determine measure of arc NP. So by using the theorems and the postulates, and is given that MK and NJ are two intersecting lines in the center, or intersect at point C. Okay, let's start. If I have measure of angle JK, arc JK, which is 27, so I can find the central angle, which is JCB. JCK is 27. So measure of angle JCK is equal to the opposite one, which is a vertical angle theorem. So MCN. So angle JCK is equal to MCN, which is equal 27. So, okay, let's know that the line MK is perpendicular to CP. So it's forming 90 degrees here. So the other half here, it is 90 degrees also. So if I know measure of angle MCP, which is 90, I can subtract the angle MCN, which is 27 that we took it from a while. So I can get this angle. This is what we are going to have. If measure of angle MCN is 27 and MCP is equals 90, by using the arc postulate or arc addition postulate, we can find it. So we have measure of arc MN is 27, as the central angle is 27, and measure of arc MNP, which is the biggest arc, which is 90, as if the central angle is 90. So here we have arc addition postulate. If we add them, we can find that if I need NP, it is MNP minus MN. So if I have 90 minus 27, it gives me 63. So this is the unknown that we must find, the NP, arc NP. Using the inscribed angle theorems and investigating inscribed angle on diameters. So here we have this theorem, inscribed angle theorem, the measure of an inscribed angle is equal to half the measure of its intercepted arc. So what does it mean? That if I have two chords and this is the inscribed angle is half the measure of this arc. So if I joined from C to A and from C to B, this is called the central angle. The central angle is equal to that arc, but the inscribed angle is half that arc. So we can say it in another form, that the measure of the inscribed angle is equal 1/2 the measure of the phased arc, the arc between these two endpoints of the chords. So measure of ABD, angle ABD is equal 1/2 measure of arc AB. Another theorem, inscribed angle of a diameter theorem. If I have the two chords and the two endpoints of the chords here are on the diameter of the circle. So the angle in front of them, or the inscribed angle here, must be 90 degrees. So the endpoints of a diameter lies on an inscribed angle if and only if the inscribed angle is a right angle. So if I have the two chords that forms the inscribed angle, the ending points of the two chords are the two endpoints of the diameter of the circle. The inscribed angle here must be 90 degrees. As I have another example, this is a triangle that I drew. So this angle must be a 90, as if this line is the diameter. The two endpoints are the diameter of the circle. So this must be 90. Another one, if I have, I have this line, which is diameter connected between two endpoints, and it is a diameter, so this angle must be 90 degrees. Okay, example 2b, page 109. Determine measure of arc WX and measure of arc XZ and measure of angle XWZ, measure of angle WXZ using the theorems and postulates. So here we have and we are going to start. If measure of WZX is half this arc, because we took it from a while that the inscribed angle is half the measure of this arc. So by using inscribed angle theorem, I can substitute that if this angle is half of that, so I can find this measure by multiplying the angle by 2. So measure of arc WX equals 2 times 9, which is equals 18. Now we found the first demand, or the first unknown. Now, if I have arc WXZ is a semicircle, so measure of angle, measure of arc WXZ is 180. So this arc, because it is a semicircle, so the arc is equals 180. Now we can use arc addition postulate by using measure of arc WXZ. This arc is equal arc WX plus arc XZ. So 180 to get XZ only, I'm going to get 180 minus that arc that we got it from the previous step, which is 18. It gives me 162. So arc XZ will be the second unknown, and it is called, or it is equal 162. Now, if I use the same inscribed angle theorem about measure of angle XWZ, so that angle, here we are, XWZ, it will be half measure of arc AXZ, because this is an inscribed angle. So what's the relation between the inscribed and the arc? So the inscribed angle is half the arc in front of it. So we can substitute half times 162, as we took it from the previous step, it gives me 81. So the measure of angle XWZ, this angle, it is 81. Now I'm going to have the fourth one, or the fourth unknown, which is WXZ. So I need to know that measure of WYZ, which is the arc, this arc is 180, as if it is a semicircle. So measure of WXZ, measure of angle WXZ is equal half that semicircle, because this an inscribed angle WXZ. So what's the relation? The inscribed angle is half that in front of it, the arc in front of it. So this arc is 180, so it will be half from the inscribed angle theorem, of course. So half times 180 gives me 90. Okay, so this is the fourth one. Example 2a, page 1009. Use the inscribed angle theorem to find the inscribed angle measures. So here we have determine arc DE. We need to find this arc DE, and we need to find arc BD, all of that, from B to D. We have to find measure of angle DAB, so that angle, all of that angle, and ADE, that angle. So we need to find for these unknowns. Using the theorems and the postulates that we took, measure of angle DAE is half that arc DE. So we have the relation from the inscribed angle theorem that the inscribed angle is equals to half that arc. So to get that arc, we have to multiply the angle by 2. So 2 times 54, it gives me 108. So this is the first one. Now I'm going to use the arc addition postulate, that if I know that arc, which is BE, and I have DE, I can find BD all by adding these two arcs. So I'm going to substitute. This arc is 18, and this arc we got, it's 108. Add them, it gives me 126. Okay, again, we are going to use the inscribed angle theorem. Measure of angle DAB, this angle is half arc BD that we got it from a while. So half times 126, it gives me 63 degrees. So this angle BAD, it gives me 63. Now I'm going to get the final one. If I know that ABE, arc ABE, it is a semicircle. Why? Because the two endpoints are the endpoints of a diameter. So this is called a semicircle. So measure of arc ABE, it is 180. So by using inscribed angle theorem, measure of angle ADE is equal half of the faced arc or the inscribed arc, the intercepted arc, sorry. So if I'm talking about these two endpoints, and this is the inscribed angle that I want to get, it will be half the arc in front of it. So it will be half times 180 gives me 90 degrees. Your turn, page 1010. If, sorry, if measure of angle EDF, this small angle, is equal 15, determine measure of angle ABE. ABE. So I need to get this angle all. Using the theorems and the postulates, let's start. If I have angle EDF, and angle EBF, they are common in the same arc. Do you see? DEF and EBF. They have the same arc EF. So if they are common in the same arc, so the two angles here are the same. So if this is 15, so the other one will be 15. Okay, measure of angle ABF. ABF. It is half that arc, because we have from inscribed angle theorem that this inscribed angle is half the phased arc that we have. So half times 44, it gives me 22. By using the arc addition postulate, measure of angle ABE is this arc plus that arc, or this angle plus that angle. So measure of angle ABF plus measure of angle EBF. So I'm going to add this angle plus that angle. It gives me 22 plus 15, it gives me 37. Thank you very much. And if you have any question, just contact me.